Okay, now, like in this example, we're going to try to apply the converting technique, like from the example 16 to like fourth order. I would like to show you like it's really possible to change like a high order differential equation to the system of first order, okay? So like this is first order, okay? So, okay, let me do the same thing, okay? I'm going to define 4 different variables, okay? First of all, x1 is y, and let's say x2 is y prime, x3 is y double prime, and x4 is y triple prime, okay? Then with this one, I can say the fourth prime is equal to x4 prime. Is okay? So now we have like all 4th degree terms, right? Now, my 4th degree differential equation can be transformed or convert into the like system of like first order differential equations, okay? Here we go. So like y4 will be replaced with x4 prime, and we define y as x1, and right hand side there's no change, okay? Then the matrix system looks like this way. We define all x1 through x4, right? x1 prime is x2, and x2 prime x3, x3 prime is x4. Then we found x4 here. Prime is minus x1 plus f of t. Can you see? Then we can write this one as a matrix form, right? There we go. x1 prime, 2 prime, 3 prime, and 4 prime. And right hand side, look at that. The first equation doesn't have like, x1, x3, x4, right? All those are 0, but there is only 1 for the second one, right? And then second equation, 0, 0, 1, 0, and 0, 0, 0, 1, and last one is minus 1, 0, 0, 0, and your x vector, x1, x2, x3, and x4, then you're gonna add the like source term like for the like very last equation only, right? Which is 0, 0, 0, and f of t. This is the way to convert like first order differential equation into the system of like, the first order equations, okay?